Hi, so today's problem is remove subfolder from file system. So here we have been given an array of string name folders. So instead of going through this, I will tell you what it is saying. First of all, what is a subfolder? Suppose in a directory we have been given a path /a. So what it represent in the root directory, there is a folder name A. But if I say /a/b, then it will be like we have a folder in A and inside that folder we have a folder B. So this folder B is called a subfolder of A. Similarly, if it is like this /a/b/c, so the structure will be like this. Inside A there is a folder called B, and inside B there is one folder called C. Then C will be a subfolder of this thing, this path. So what we have to do in this question is we have been given some path like this, like for example /a and /a/b, and they are telling us to remove the subfolder. So from this, and we have to return all the valid path after removing the subfolder, and they should be unique. For instance, if we consider these two, we can see that the subfolder is here only /b, so the path which we have to return will be only /a. If we take these two into consideration, if this is not in the picture, then /a/b, then what we have to remove, we have to remove this part /c here, and we have to return this value. And what can't be a valid subfolder, suppose we have been given something like /a/b/c, it is represented here, and we have been also given something called /b. So it will be something like this, a folder on the same level of A. So as you can see directly here, this B and this B are on different level, like it is the root level, and after that there is a B. So this thing and this thing is not same, hence we cannot remove C. It will be wrong. That's what it is stating here, that if there is a folder ABC and we have another folder /b, then we can't remove it. Like, okay, read it from here. For example, /a and /b is subfolder of /a. Yeah, that is right. See, /a and /b, it is, this portion is a subfolder of this. This is correct. But this /b is not a subfolder of this thing. Why I am saying this? If we follow the hierarchy, we can see that this B and this B are on different levels of hierarchy. So we can't remove this. So if we have something like this, what we will be returning is /a/b/c and /b. Sorry, not arrow. And /b. These two things will be returning. So now let's quickly run over the examples, and after that we will be going through our idea. So let us see our first example, that is /a. Let me /a/b, then let me write /c/d, and again /c/d/e, and /c and /f. So if we start from here, we take this string and we see, okay, this is not a subfolder for any folder, so we will be inserting it in our result. In our result we have something like this. Now we come to second string. Now if we compare this /a, this is the inserted string, and /b, we can see something like this. What we can see, this is a common part. So this /b is a extra string, sorry, The slash b is the subfolder and we have to remove it. So if we remove it, again we get slash a, so that is already inserted, so we won't be inserting it. Now we have processed this, now we will come to this. Again we only have slash a, and since it is not even starting with slash a, so this can't be a subfolder of this, so we can directly insert it. Again, okay, we got an interesting thing. Slash c slash d, we can see as it is written that a subfolder folder j must start with a folder j. How it can be a subfolder? A possibility is there. How? Because it is also starting with subfolder j. If we consider it j, the subfolder of j, what it should do, it must start with j. So if we start with j, we have something like this, and then after that it is written followed by slash. If we see, this thing is common again, and it is followed by the slash. Here we are going definition by definition, so we can surely say that this part is the subfolder and we don't need it, so we will be removing it. Hence if we remove it, we won't be putting it into our result array. And again slash c slash f, but here if you see, it is starting with this thing slash c, but on the second half it is not slash d, it is slash f. So you can say something like this: this is not a subfolder, and we will be putting it into our result. Suppose this is something called slash c and slash d. It can be represented something like, here we have a folder that is called d, and we have something same path slash c and slash f. So it is the first hierarchy, and then we have another folder f, and this d and f are on the same hierarchy or same level, so we won't be removing it. So hence we have got this answer: slash a slash c slash d, these things. Yeah. Similarly, let's quickly go through second example here only. Again if we see slash a, it is the common point between this is an interesting example. We have slash a, again slash a, slash b and slash c, and third one is slash a, slash b and slash d. So little optimization we can do. First we have inserted this slash a. When we are processing it, we find something common. As soon as I find something common, why should I process more? Like, I know the rest of the part will always be a subfolder of slash a, so I won't be inserting it. Again if I come here, I will be start processing it slash a, I got something in common. This again slash b and slash d will be a subfolder, so I won't be inserting it. So here we are somehow like saving our computation, like we are not processing all these elements. As soon as we get something in common, we know that the rest of the part will be a subfolder, and we will not add it into our result. Similarly for the last one, slash a, like if you see that here, okay, again let's see. First we have this, then again we have something like this. In order to be subfolder, it should at least contain this, and after a slash something should be there. But if you see, only this part is common, after that it is not common, like I have explained here. So these are not a subfolder, and both are added to our result. Again the same goes for this. They are on same hierarchy, like these two things are same, but this c, a and d are on the same hierarchy, hence they are not a subfolder, so these three are added. Now let us see the intuition to solving a problem. The first problem which I was facing, how can I detect a subfolder? So let us take an example. This is a path 1 and this is a path 2, or let us make it more broad. So when I observed carefully, then I started to see a pattern. This whole word is present inside this. this whole string is present inside this. So I can surely say that if one string is wholly present inside another string, then this part, okay, let it be more visible, this part is a subfolder. Similarly, this part is a subfolder. So the result which we should get in our result array will be this. So what we concluded from this, if we have already seen a string and we again encounter that string, then anything after that string will be the subfolder. So that's how I can always detect that this string contains a subfolder if I get to know the common part. So second thing that is coming to my mind is that the order in which we process the strings, do it have to do anything with the result, or will it simplify anything? Up till now we have seen that we have a string something like this, and suppose if we are able to find a common path between both the string, then I can surely say this path is the subfolder. So let us take an example. First I have a string something like this and another string is something like this. Second, I have a string something like this and another string something like this. For first example, I start processing the string, and let us say I have taken a function or a data structure. From that, if I see that I have already encountered this string or not. So suppose I have taken T and I am starting here. I processed A, I added it to my temporary string, then I got this slash. So as soon as I hit slash or I reach the end of the string, I check whether I have seen something like this earlier from my this dataset. We will come to it which dataset we can use. Currently we can think it is something a helper that is helping us to find if we have seen this string earlier or not. So I can say no, I haven't seen this. Then I am adding it and again moving forward. Then again, as soon as I encounter a slash, I check whether I have seen this complete string somewhere earlier, but we haven't we don't have anything inside this. So again we move forward by inputting it, and again we reach the end of the string. Now again we are asking whether we have seen this complete string somewhere earlier, but again this structure is empty, we haven't inserted it anything, so no. So once we have we are done with this, we can insert it in this. Now I start processing this from A. The first one, as we can say, it is common in all. We can do a optimization and start, instead of 0 index, we can start from index 1. So again I come to A, I see A, okay. Then I ask, have I seen A? But we don't have anything here as A. Then I move forward. Like after slash I check again, have I seen a string like this? But we don't have anything like this. Then I move forward and I append B. Then I move forward, and if we reach the end of the string, we again check, have I encountered anything like this? But here we only have something like this. So we put it into a structure. But for this case, we start from here. Okay, we append X and then we move forward. Okay, we reach the end. So we check, have we find anything like this, or we have seen anything like this? No, we put it into our helper data structure. And then we move forward to processing this. Again I will start from here. I put X here. Now if I move forward, okay, I found a slash. Then I ask, have you seen something like this from my helper? Now the helper has something like this stored. It will tell yes. So we are able to find the common part, and this helper told us yes. So I can surely say this green part, it is the sub array, and we don't want it, this string in our result array. So what we can see here, how the order help us? Yeah, there is some ordering if you compare these two. How they are ordered. See, what is the possibility that I find the common part first? If we process the smaller string first, suppose we have a string something like 1 2 3 4, and we have another string 1 2 3 4 5. So how first processing the smaller string will help us is that the possibility of being the smaller string as a starting or prefix is much higher. If we process the larger string, then we can't get this smaller string. Like if I process this first, I won't be able to find this prefix. But if this prefix is already stored in my helper, and if I, after processing it somewhere, I come here, and at this point if I ask, have I seen this earlier, and my helper tell yes, so I'm easily able to see that I have such kind of prefix already stored in my helper structure, and this part will be a subfolder. Now again coming to third intuition, I was telling this was a helper data structure, but what structure can we use that can give us this result quickly? So why not we use here unordered set of a string, and now our approach simplifies. Only three things we have to keep in mind from the intuition, that is, we need to find common part, or better to say common prefix. In such kind of problems we generally use try, but I feel in this problem try is a overkill. We don't need try, we can solve it using a unordered set. Second thing, order is important. If we process first the strings that are smaller in length, and after that the larger strings, then the tendency that this string might be a prefix is more, and we will be able to catch that prefix. That's why order is also important. And third, which data structure I can use for a helper, so that will be my set. We could use it via try, but in this case I think a set would also do. Now let us understand what will be our approach from the three intuition. First, we have been given this array of a string folder, so I will sort it based on the length of the string. So it will be now something like this: /a /b /cd . Okay, now we have sorted our input based on the length of the string. Now here we have a set, unordered set. So, and we have a helper string temp that will be empty mostly. So first we started with this first element and we started processing it, and we processed a, we added it a, but as soon as we reach the end we will ask whether we have seen, hey set, we have seen this a earlier. The set says no. Oh, so I can simply insert it in my set again. Then I will move forward and I will process this slash second one. And as I told, we can remove like in every string we have this common first slash. So instead of that, I start from index 1. So again I processed A and then I moved ahead. And as soon as I encounter a slash, that means that up till now can be in the set, and after this we are starting a new folder, so it can be a subfolder. So till now we have A in my temp, and I asked set, hey set, have you ever encountered A before? And set says yes. So now we knew that we have a common part between this and this, that is A, and hence we have seen that if we have common part between two strings, then surely the longer string will be a subfolder of the previous string. So here this portion is subfolder, so we won't be adding it to our final result. Okay, we will add it in the end. Basically now we will move here. I start processing by C. Yeah. Then I encounter a slash. Oh, I'm asking my set, hey set, have you ever encountered a C? But set said no. Then I move ahead. Then I add D, and then I come here. And then ask, hey set, have you encountered something a string like this, C/D? Set says no, so we insert it in the set. So now I will move quickly. For third one, we came to set, we asked set, is C present in you? The set says no. We move forward, we append, we add, and again we ask, do you have a string something called C/F? The set says no. Then it means that this is the first time we are encountering, and it can't be a subset, so we add it in our set. We again move forward. Now to X and Y. I first encounter X, then I encountered slash. So I will ask, hey set, have you ever seen X? The set says no. So yeah, we move forward and we add Y, and then we come at the end, and then again ask, hey set, have you ever encountered this type of string? The set says no. So yeah, we put it into a set and move forward. We came here, we inserted C. Ask set, hey set, have you ever encountered C? The set says no. We move ahead, we encounter slash, then we encountered D, and again when we encounter slash, we ask slash, hey set, have you ever encountered C/D? And the set says yes. Then we can say this is a common area, this is the common part, sorry, and we can surely say in our example, this is the common part, this is the common part. So as soon as set tells her, yeah, I have already seen it, so we have a common part of this string, and the next part will be a sub folder, so we won't be adding it, and we will move forward here. And we have added X. Then we move forward and we add a slash. Like as we encounter slash, we ask, have you ever seen a X? Set says no. We move forward, we add a Y. Then again we encounter a slash. It might be a possible beginning of a subfolder, so we ask, the current string, have you seen it set? And the set says yes. Then again we have found something common, and now we know that again this part will be a subfolder, so we don't add it to our set. So if you see, the elements in our sets are the final result of our array, so we can simply put these elements into the set, or you can do it side by side. Like if I am able to insert an element in a set, that it means then that it will be in my final array. Now let us move to code quickly. Okay, so let us start. So first of all, I'll be taking an unordered set of a string. And simply I will sort my folder on the basis of size of the string. So folder dot begin, comma, folder dot and I can write a custom comparator function, compare by length. Bool. Now I will write a static because we are internally calling it without an object, so bool static and compare by length. That will be taking a const and we count a string a and another constant string b, and we will simply return if size of a is less than size of b. Now we are done with this, so we will create another result vector that will be result. Okay, after simply we are traversing the path from folder, and we will be checking a function insert path. If it is true, then it means that we haven't encountered this string yet, and it is a brand new string and it can't be a subfolder. So result dot pass back path, and in the end we will return result. Before that we have to write a function insert bool insert. Here what I am taking, I am just taking a path and then size of the string, and after that a temporary string, and as I told, I will be starting my iteration from 1 and till n, and if I encounter a forward slash, then it may be the case that a new substring is starting and we might get a subfolder. And another thing, if we don't put this condition I equal to n, then when we have processed slash a, but we will be never processing or checking after a string is completed that we have seen it or not. It may be the case that our input is /a and we are never checking once we are at the end of the string, so we have to do that, and then I will simply find it in my set. If it is present in my set, then it means that we already have some common prefix and we will return false. And if I is not equal to n, then I am simply adding everything to my string, and if we have successfully come here, that means that it is a unique string and we will insert it into our unordered set and we will return true. Now try to run it. Okay, it is running. Now we will try to submit it. As you can see, it is pretty good. The length of our array we are considering as n, and the k is the average length of the string in the array. So for time complexity, first of all, we have sorted the array, so that will be n log n. After that, for each string we were traversing it, so it will be n into k in worst case scenario, and we are using unordered set, so the insertion is constant, so we are not writing it, otherwise it can be a constant operation, or we can say constant into n, because in worst case all the strings are unique and there is no subfolder. So this will be a time complexity, and our space complexity can be O of n, like we will be inserting all the elements in worst case because all of them are unique.